Hey algebra students, I wanted to talk to you about the lesson 8-1 just for a little bit and then go over a couple problems that you had to do on your homework. So I think most of you probably did fine with this lesson because it was all about combining like terms through adding or subtracting, whatever it asked you to do. So please make sure though that you've read over this vocabulary and try to make some sense of it. And of course, look over the examples as I always tell you to do. So reminder, like terms, up till now, you've never had to worry about, like terms other than just terms that had variables and terms that didn't. So these were like terms because they had the same variable x, whereas these were like terms because they were both constants, so they could be combined together just as these could be combined together. If it was at addition, right, it'd be 6x. If this was subtraction, that'd be -4. Okay, but in this chapter they started showing you the terms got a little bit more involved. So we have on number, I would like to look at 43 and 44. 44 especially, that was the one from your homework that you could not check the answer to in the back of the book. And some of you that have already submitted your homework, I saw had this incorrect. So I want you to make sure you are looking at this one with me and trying to make sense of it and fixing that homework assignment, that homework problem if you got it wrong. So I picked number 43 to look at though first from page 469 because it was a subtraction problem. You were subtracting polynomials on this one, and it's a long problem here, so let me kind of move out here a little bit. So I already marked the like terms. So this 4 rxt and this positive 5 rxt, those are like because they have the exact same variables raised to the same power. And then we also have x squared and then a -2x squared. So be careful, these other terms that are not underlined, they are not like terms because they do not have the same variables raised to the same power. On this one, r squared, r is being squared, and on this one, r is not being squared. Okay, they look similar, but they are not the same. They are not like terms. So I picked a subtraction problem so that I could show you about this real quick. This whole right polynomial is being subtracted. So make sure, that you can, this is one way to handle that. I'll use orange pen so you can see what I'm doing. Make it addition, and every term in here, all three of these terms have to become their opposite because we're making it addition of the opposite. So this would now become a -6rx squared. This would become a -5rxt, and then this would become a +2x squared. Okay, please make sure you do that just real quick. Jot it down on paper. Don't try to do it all in your head. You will lose track. Okay, then from there, I already marked the like terms. So these two together would make a -1 rxt. So you can just write that as -rxt. If you want to put the 1 there, you can. It's not needed. And then you can go and start writing these separately. You cannot put them together again, so I'm just copying that down. -8r squared x. And again, this would be a -6rx squared. Cannot put those two together, cannot combine them. They're not like. And then lastly, we have x squared plus 2x squared. That would make a +3x squared because that's known to be a 1x squared. All right. So number 43, that's one way you can write that answer. Okay, and then number 44, they told you that this equation represented the number of dogs, this equation represented the number of cats, and on letter A, well, another important thing I wanted to make sure you made note of, it said where N is the number of years since 1999. That is critical that you notice that and take that into account, okay? So on A, they asked you to write a function that models the total number T of dogs and cats adopted in hundreds for the time period. So I used T because it asked me to write a function for the total number T of dogs and cats. So this, remember, function notation, it asks you to write a function. The best answer would be to write it like this. The T of N, okay, N's the variable, that's why N is being used. And then they told you to use T to represent the total number. So 3n plus 7, that came from you combining the like terms up there for dogs and cats. So there's 3 n's, because this would be a 1n. And then 3 plus 4 would be the plus 7. And then letter B said, if this trend continues, how many dogs and cats will be adopted in 2013? So up in the problem, they had told you n is the number of years since 1999. So 2013 would be 14. N would equal 14. Okay, so all I did here then was plug in 14 for n from this equation up here. And when I solved it, I got 49. So one more thing, some of you left the answer as 49, but it had mentioned up here that the cats and dogs, the numbers given were in hundreds. So if you got an answer of 49, that's really 4,900 dogs and cats. So again, double check number 44 especially, because that was one that you were not able to check in the back of the book. See how you did, and make sure you are submitting to me the homework for lesson 8-1. See you later. Bye.